Hi friends, welcome to NIKRA'S Expert Learning. Today we are going to see about pile foundation. Let us first understand what is a pile. A pile is a structural member which is slender. Okay, that is made up of concrete, wood or steel. So here we go for pile foundation whenever the soil near the ground surface is not capable enough for assisting the structure above the foundation. So here we'll be using some deeper foundations like piles, piers or caissons. So that will be transferring the load to a greater depth. A pile is either driven into the soil or formed in situ by excavating a hole and filling it with concrete. So here we have pier. It is installed in a dry area by excavating a cylindrical hole of larger diameter to decide the depth and then backfilling it with concrete. So here first of all we are just digging a hole, and to this hole we are filling in this concrete. So there is the foundation. This is the foundation that is formed. A pile is greater than 0.6 meters diameter is generally termed as pier. Whenever a pile which is greater than 0.6 meters is formed, we are terming it as pier. Okay? And caisson is a hollow watertight box or chamber which is sunk through the ground for laying foundation under water. So whenever we are laying the foundation under water, we are forming a hollow structure or chamber which is watertight box. We are calling it as caisson. So what is the requirement of this pile foundation? What is the necessity? That is, when below strata of the ground surface is very weak to take the loads that are applied above it, we will be using this pile foundations, that is deep foundation. So pile foundations are required for transmission of structural loads through deep water. So whenever we are transferring the load, we are allowing it to transfer it to the lower depths. So what is the necessity? We have seen this. Next, classification of piles. First comes according to the materials. According to the material, we have timber, steel, concrete. So we have more. Generally, we are using timber that is made up of tree trunks. After proper trimming, timber used should be straight, sound, and free from defects. So whatever the timber is there, it is properly seasoned to remove all the defects. So that then we are using in these piles. Next comes the steel piles, which are generally either in the form of thick pipes or rolled steel head sections. Pipe steel piles are driven into the ground with their ends open or closed. Their ends may be open or closed ones. So depending upon the requirement, we are choosing the cross section of that steel pile also. Next comes the concrete pile. Cement concrete is used in the construction of concrete piles. These are either precast or cast in situ. Precast is prior to the construction only we are casting the concrete and we'll just be placing in its position. Cast in situ is we are casting on the site. Okay? Are prepared in factory or casting yard. So the reinforcement is provided to resisting handling and driving stresses. Whatever the stresses that are yet to be developed because of the application of load, we will be analyzing prior to the application. So during the design only we will be analyzing whatever the loads that are applied, and depending on that we are designing the reinforcement. We are providing the reinforcement. So here the precast piles can also be pre-stressed one, where we use the high stressed steel and pre-tensioned cables. So here we are tensioning the cables and then applying the concrete, that is pouring the concrete in that marble. Next, cast in situ piles. That is, we are casting on site. It is constructed by making a hole in the ground and then filling it with concrete. It may be cased or uncased. See, cased is nothing but we are having some casing. That is, it is constructed by driving a steel casing into the ground and filling it with concrete. Casing is nothing but just like a mold. We are just providing some mold for the concrete to be in its place. Next, uncased. It is constructed by driving the casing to the desired depth and gradually withdrawing casing when fresh concrete is filled. So here we will be providing the casing, but later on whenever the concrete is poured, we are removing it. Simultaneously we are doing that. Next, based on the mode of transfer of loads. That is, on which part the load is transferred. So end bearing piles. Here the name itself suggests that is end bearing. That is, they transmit the load through their bottom tips. Whatever the end part is there, the tip part is there, we are transferring the load with that. So they act as columns and transmit the load through weak material to a firm stratum below. If bedrock is located with a reasonable depth, piles are extended to the rock. So they are known as point bearing piles. See, end bearing piles are also known as point bearing piles. And remember, here the load is transferred through the bottom tips. Whenever the load is taken by this member, it will be transferred to this bottom tip. So through that only it will be transferring that. Okay, whenever, see, this is a soft soil, whenever we are able to get a hard rock below that, we'll be going up to that depth. Okay, at whatever the depth the hard rock is available, till that depth we are extending this foundation. Next comes the friction piles. So here the ultimate load carrying capacity of this pile is QU. Whenever we are writing U, that means ultimate of this. Q is nothing but load carrying capacity of the pile. So the load carried by the point or bottom is QP. The whole pile we are writing it as QU, whereas only the bottom one, if we are considering, that is QP. Next comes the friction piles. These piles do not reach the hard stratum. They transfer the load through skin friction. That is through this. Whatever the skin, that is whatever the material that is right beside this. Okay. So because of this, whatever the load that is acting, it is transferred from this direction. So in this direction, whatever the load is applied, it is transferred. And here we are transferring it through the end tip. Okay. Remember here the main part of this load transfer is skin friction. That skin friction is between the embedded surface of the pile and the surrounding soil. So whatever the surface of pile is there, and also between the soil next beside it. Okay, the soil and the embedded surface of the pile. They are used when a hard stratum does not exist at a reasonable depth. See, if we are having a hard stratum at a reasonable depth, till depth will be extending this. But whenever we are having hard stratum at this level, it is very uneconomical to provide a material or to provide a foundation up to this depth. So here we are just cutting the surface, but here we are allowing the transfer of load in this direction. Okay, from the skin. So the ultimate load QU is carried by the pile, whereas the load transfer is skin friction. We are writing this QS. Okay, we have combined end bearing and friction piles. That is both combination. Here the ultimate is nothing but summation of the skin friction one and the point one, the point end bearing one. Next, based on the method of installation. See, driven and screwed one, jacked piles, bored and cast in situ piles, driven and cast in situ piles. I explain you. Driven is, they are driven in the soil by applying blows of hammer. See, generally we will be just precasting the member, and in the hollow space we will just be hitting the material with some hammer such that it is fitted into this depth. Okay, that is one driven one. That is the driven one. We are applying the blows of hammer on top of that such that it is fitted in this position. Next, screw one. We will be applying a screw and jack connection in this. Whenever we are just driving a hole to this, we will be providing a screw and jack friction over here. See, such that whatever the pile is there, it is automatically fitted in that position. Okay, jacked piles, bored and cast in situ, driven and cast in situ. See, bored and driven. These are the methods by which the cast in situ piles are placed in this position. Next, based on use, load bearing piles. That is used to transfer load of struck to the suitable stratum by end bearing or friction or both. So here whatever the mechanism of transfer of load is there, here we are just seeing what is the use of using that. Okay, with what requirement you are going for this pile foundation. If you need the load transfer mechanism, then we call as load bearing piles. Next we have compaction piles. That is, whenever you are having a loose granular soil, to increase the relative density, sometimes we just compact the soil, right? So whatever the piles which are used to compact the material, we are calling it as compaction piles. So the bearing capacity of soil is increased due to densification caused by vibration. Here we know density is equals to mass by volume. So whenever the volume is reduced, see, whenever we are compacting, initially the soil volume would be this much. Whenever we are compacting, it would be reduced, right? So whatever the volume of soil is there, it is reduced. Whenever the volume is reduced, I can say the density is increasing. Okay, so because of this densification, even the bearing capacity of soil is increased. So that is why we use this compaction piles. Next comes the tension piles, sheet piles and anchor piles. For anchoring purpose, we use this anchor piles. Next, according to the L by D ratio, that is length to diameter. This is the length of the pile, whereas this is the diameter of the pile. Okay, so length to diameter ratio, we are classifying it as long pile and short pile. The long one is termed as flexible one, whereas the short one is rigid, because short one will always fail by crushing, whereas the long one would always fail by buckling. Remember this, long one will buckle, short one will crush. The short pile, when L by D is less than 10, L by D is less than 10, behaves as a rigid body and rotates as a unit under lateral loads. So whenever the lateral loads, see this direction loads are applied, it will rotate. Okay. Next comes the long pile. The length beyond a particular depth loses its significance under lateral loads. See, as they are long enough, as the L by D is more, here we can say up to certain depth only, the significance of this lateral load is there. After that, they are not much affected by these lateral loads. So whenever the vertical loading is acting, the frictional load on the sides of the pile bears a significant part to the total load. So here in this case, the vertical loads are main term to be considered, and they bear a significant part to the total load. That is it for this video, guys. If you like this video, please like, share and comment to the channel, and don't forget to subscribe to my channel. Thank you.